In this lesson, we're going to take a look at multivalent ionic compounds, what they are, how to name them, and how to write their formula. So multivalent metals, most of the transition metals, so that middle chunk in the periodic table, the metals that we think of when we think of metals, so things like iron and copper and zinc and nickel. Many of those can form more than one type of ion, so they have more than one option for how many valence electrons they have, which means they have a different number of electrons that they can lose. The reason this happens is because of the amount of energy it takes to fill electron shells can be different, and so we'll take a look at that in 4U Chem in more detail why that happens, but it has to do with the different types of electron shells and what those start to look at beyond the third level. So any of the metals that can have more than one valence are called multivalent. And the place that you can look that up is in that My Best Friends sheet that's part of that periodic table that you have. And we can see here that we have the different elements, their symbol, and the possible valences that can be created. So iron, for example, can either have 3 electrons in its outer shell, which it loses, or it can have 2. Copper can have 2 electrons or 1 in the valence shell, and so when it loses them, it can become a copper 2+ ion or a copper 1+ ion. Okay, so for example, iron, we just looked at that, can make an iron 2 or iron 3 ion. So because we have more than one option for these multivalent metals, it means that when they combine with the same nonmetal, they can make multiple different compounds. So if I take copper with chlorine, copper could be a 1+ or a 2+ that we just saw. So I can have a 1+, or I can have a 2+. And chlorine is in group 7, needs 1 electron that it would gain, so that would be a 1-. So if I follow my rules from before, I'm going to crisscross those, and that gives me CuCl. So remember, I dropped the 1s, and here I have CuCl2. So I have 2 different options for what can be created formula-wise. If I were to look at naming before, for ionic compounds, I take the name of the metal, so copper, and I take the name of the nonmetal, drop the ending to the name, and add "ide." So copper chloride. But I can't have CuCl and CuCl2 both be copper chloride. So we need something else to name these properly. So what we use is the International Union of Pure and Applied Chemistry for a system of rules to name compounds. There used to be a different system that was used, but this is a lot simpler. It's simply based on the valence that that particular ion forms. So the name of the metal ion is going to include the charge, just the number, not the sign, with a Roman numeral in brackets. So for copper, there was copper that could make a 1+ or copper that could make a 2+. So copper 1 and copper 2 are what we refer to those different valences. So CuCl, that one was made with copper that had a charge of 1+. So that is going to be called copper 1 chloride. And CuCl2 was the one where we had Cu2+, and so that's going to be called copper 2 chloride. So we have the same system of naming and coming up with the formula as we did before, except that because we have multiple options here, we don't only have one valence. We are going to use that Roman numeral in brackets following the multivalent metal to identify which of the possible valences that happened to be. So to come up with the name, we have to figure out what charge on the ion would give us 0 charge overall. So this is the working backwards. If we are given the formula, how do we figure out which of the valences it was? So for example, I have tin chloride here. So chloride I already know is a 1 minus. So if I work backwards, I have tin and I have chlorine. And if I do my crisscross reverse, the 2 goes there. There was a 1 here for the tin, which isn't shown. So that means I have a 1 minus and a 2 plus. And here, I do have to look to see if lowest terms had happened. And I use the one I know for that. So chlorine is giving me a 1 minus, and chlorine actually does have a valence of 1 minus. So it's in group 7, it would gain 1 electron, becoming charge 1 minus. So that means there was no reduction to lowest terms. It was already in lowest terms, which means the 2 plus on the tin is the correct valence. And so this is then going to be called tin 2 chloride. So the other way that we can do this is chlorine is a 1 minus. Because we have 2 of them, the total negative charges is 2 minus. And so to combat that, to balance it out, we need a 2 plus on the tin. So once again, there's multiple ways you can do this, whichever one makes sense to you. So tin 2 chloride is the name for SnCl2. And if you're not sure if you need to be doing this valence, because this should only be done if it is multivalent, remember you can come back to here to check it out. And I can see here tin can be a 4 plus or it can be a 2 plus. So the classic naming, I'm only going to show you this just in case you see these names so you know that this used to be used. Instead of the numbers, so CuCl would have been called copper, or sorry, we do call it copper 1 chloride. That one used to be called cuprous chloride, and then the other one, the copper 2 chloride,